All right, welcome back to CSIS 1190. We are going to carry on with chapter number 7. We're in week number 10. Time is flying by. In this chapter, we're focusing on some of the more advanced formulas and functions that you guys could come across. These are, we're going to be extending what you already know in this chapter to a degree and introduce a few new features. We're going to use the textbook example, I think, for this lecture to go through. It'll correlate with your simulations, and I think it'll make it a little bit easier. You do have access to the resource file when you guys go into the Blackboard course or the MIT Lab course. You can click on student data files and you can download the file and work along with me on this one. I would highly encourage it. And again, remember, this is kind of like your in-class lecture component that you would normally do. Now, this chapter is broken down into three kind of main categories. The first one we're going to look at is formulas to calculate dates, logical, and lookup functions. So we'll have an introductory look at date functions, and there's quite a few of them. Now we're going to look at one of the more complicated formulas that you're going to run across. It's the if statement, and it's a nested if statement. And you can also have if statements with logical operators like the and the or. And to a degree, this is almost a programming concept, so I'm going to go over this with you. We're going to look at another advanced lookup function. We've done vertical lookup. You might have tried horizontal lookup. We're going to look at one here called the index function mixed in with the match function. So we'll go through that. We'll also look at how to filter data, and we've done some of this with the sorting and the filtering with the built-in tools, but now we're going to look at the advanced functions for filtering, which is just a continuation. Also, we're going to add is the ability to do aggregate calculations on a data set. So there's a whole series of functions called the data sum. We know everyone knows what sum is. They all know what average, but this would be data sum, data average, data min, data max, and data count. And there's other ones as well, but this gives you guys at least an understanding of what the data functions, aggregate functions are. And then we'll wrap it up with some financial functions. Now we've looked at the PMT, how to calculate a payment. We've looked at that quite a bit. But we're now going to look at how you can calculate with other arguments, the arguments of the PMT. So present value, the future value of an investment, the net present value, the number of periods that you need to amortize over, and the APR rate that you might need. Also, we'll be looking at the I payments and other financial payment systems, an example of that as well. All right, so that's what we're going to cover in this video. And so to get started, I would encourage you guys to open up your sample. And what they've done is the book will go through and explain all of these learning objectives, like the logical lookups, the database functions, and the financial functions here. So again, this is available on the download that you guys can get, and I'll see if I can post it on the Blackboard site as well, make it a little bit easier. All right, so to get started here, like any of these, we really want to understand what you're looking at. So the role that you're going to be playing in this example would be working with an accounting component with the human resource department. So you might be working in a company and need to help them create or calculate some additional information. So what they've done here is at the top, they put in some looking up or some rules that they want. So some places for you to enter data. Now, personally, I tend to always highlight things with yellow when they're an input fields. So these would be some input fields right here, that those three right there that you could type in. For example, the employee ID. So there's a database of employees and their IDs are here. So I'll just use the second one just to show you how that works. So I would say that this is the second employee. So what I want to do is be able to click on this and actually look that person up and try to pull out that information. All right. Now, the table itself, of course, has the employee ID. It's matched up with the person's last name, where they work, what their title is, when they got hired, and what their salary is. That's all the data that you have. So what we're trying to calculate is years employed. How long has the employee been with the company? Now, this might need to be calculated for a variety of reasons. In this example, they're going to say, well, based on how long they've worked, we're going to give them a bonus. So the company has decided to organize how much they want to give out their employees based on how long that they've worked. So we first need to know how long that they've worked. We know what their salary is because we pay them, so that's an easy one. So we want to calculate that. Then we want to calculate what their bonus is going to be. And then this one here called the raise status, and we'll calculate that one as well. So there's a few things we need to do. All right, so to get started, I'm going to go in and calculate using the date function. So I'm going to go in here and I'm going to calculate the years employed. So how do we calculate that? And you know, there's always different ways to write formulas. So what I want to do is just introduce you to a new one here called the year fraction. So by hitting the equal key and typing in year, of course, the formulas that match the search pop up automatically. So I've got one here called just what year is it and what fraction of a year. So if I just use the year one, it just, okay, well, what year is this? Well, that's 2007. That makes sense. So we can extract just the year. But I want more than that. I want to know the fractional amount. How much has it been since they've been working? So I'm going to click on this one here, and it comes up with two arguments: the start date when they started and the end date of when they finished. Now that's a kind of a tricky thing, because when does someone finish? Well, we can do it in a couple ways. We could do it statically, or we could do it dynamically, meaning that we could do it from a static date when their last day, or we could do it from the current date of whenever this is being viewed. So I'm going to start off with the first one. This is what the book does. It says, when did they start? All right, so I'm going to say, I'm going to do that again, equal to the year fraction. The start date is going to be the higher date, and it's kind of unfortunate because this formula actually overlapped my field, so I have to use my arrow to the left key to get access to the E7. And this is a relative because I want this relative for each person, so that's my start date. Now my end date could be up here as the last day of the year. Now that right there, is it relative or is it absolute? Meaning that when I copy this down, do I want this to be copied down with it relatively, or do I always want to use the same? I always want that same. So I can push the F4 key, which locks it in place. Now, because I'm only pulling it straight down, I really only need to lock in the row. I don't need the column lock because I'm only pulling this down. So this would work, the $2, or of course you could just lock both. That would work as well. Now, when I push the comma key, you'll notice it goes to the third argument. And this one is in brackets, and it's giving you some very subtle options here of how different countries manage dates, because they calculate dates with stat holidays and stuff like that. So for the most part, the default is 365.25 days, I believe. So I'm going to leave this just at the US standard one right there. And it's based on this 30 divided by 36, 360. Anyway, let's just leave that out completely. You'll notice that that argument is in square brackets, which means it's optional. You don't have to put it in, and usually the default works, but not always. Anyway, I'm going to close the bracket, and it comes back, and it comes up with this large number here, this 11.21 years. But if you look at my end date, that's not today's date. That's just an old date that they put in there. Now I could put in today's date. Now at the time of this recording, I could put in a static date. I could say, well, I want it to be, let's say July the 12th of 2021. But by the time you watch this, that's not going to be the correct date either. You'll notice when I put that in, it automatically changes to 13.74444. Now that's a static date. If I leave it like this, it's always going to be there. But if I put in another formula here, a dynamic date, I could say, well, what is today? Now you remember that today has no argument. You can see here I put in the function called today, and there's no argument because you can't argue today is not today, because today is today. It's always today. It's kind of like a constant that always changes. All right. So today is, there it is, July 12th, and that's what it is when at the time of this recording. When you guys are watching this, it could be a later date. But it's going to be the same here. This is going to constantly be changes. It's dynamic. So when you write these formulas, you have to ask yourself, do you want them to be static at the moment that it's done, or do you want them to be ongoing or dynamic? And that will impact how the function is written. Now, if another thing here is when I do the date here, I can also always go up in here to the FX, and that brings in my wizard to kind of help me out with my arguments. So the start date is here. This is going to be relative because I want this to copy down with these ones. These are all related or relative. This one here at the top, of course, is absolute, so I've locked it in. And it all looks pretty good. I think I'm just going to say OK. And from here, I could just drag it down to the bottom, or I could double click it. And it would go down. Now, I'd probably also want to fix the, make it look a little bit better. There we go. Perfect. Now, I said that there's other ways of doing this, and there is. Now, another way we could calculate this is just through logic. If you were to think of this logically, we could say, well, let's write this as a formula rather than the function. Now, this was using the function method. I used a function here called year fract or year fractional. And now I want to write it as my own personal formula. So I could say a formula would say equal to, but I want to say, okay, I want to take today's current date. Now that's right here. Now I could type it in as a dynamic, or again, I could type in the static date. And then I'm going to subtract it from the date that they were hired. Now remember that dates are actual numbers, so we can use them in mathematical calculations. And it says here, comes up with this 5,020. Well, that just means that there's been 5,020 days since this person was hired. So the formula reads, as you can see, the date is minus the start date. Okay, and they're both relative. All right, that's fine. But I want the number of years. Well, we know how this is the number of days. Well, how to get the years? I simply just take the whole formula and I divide it by 365.25. The 0.25 is just to include leap year, because every 4 years we have to add a day. So technically every year is 365.25. All right, so and we come up with the same number. So here's a way we could do it using a function, and this is a way we could do using a formula. Even though there's a function involved here, but the function, I could have typed in the actual static date right there as well. Anyway, I want to give that to you as a little demonstration that you can do things in multiple ways. All right, so let's just delete out that column. We don't need that. All right, so hopefully that makes sense. Let's move on to the next one. Now, this one here is one of the more one of the most powerful features that you can do in Excel. It's a conditional if statement, and it's where you get into more complicated questions that you're trying to answer with the data. And the question I want to answer here is I want to use this field up here to be able to calculate the bonus that this individual is going to get for each individual. Now the rule is based on when they got hired, they're going to get a percentage increase or bonus of their current salary. All right, so what are we going to do with this? Well, we're going to say here under bonus, we're going to say if this person is working more or before this date, then we're going to give them this amount. If it's before this date, we're going to do this amount. And if it's before this date, we're going to give them 3%. So now this person has been working here since 2010. Oh, sorry, this person, let's do Adams. Adams is the first one. Adams is working since 2007, so definitely gets 9%. So we want to calculate 9%. So we'd say plus this times 9%. Perfect. But we'd have to do that for each and every record. And if there's hundreds, of course, this would take a long time. Now, this one right here was hired after 2015. So they only get 3%. So I'm going to say equal to their salary times 3% equals. All right, keep going. And this one here, I got to look carefully now. Is that this one here is after this, but before this, so it's 5%. Okay, so it's equal to this amount times 5%. And then this one here is before this, so it would be, is it 9% equal to this times 5%. Oh, I made a mistake. Now, if I'm doing this myself, it's going to take a long time and it's prone to errors. So of course, this is a very poor way of doing it. But if you go through the exercise manually first, it helps train you to understand how to write the condition statement. So again, I'll do one more here. You have to, first of all, you have to look at this date and you have to say, is it less than this? Is that true? It is true. So then if that's true, select this. And we're done. Okay, what about this one here? Let's go with the 2014 of June 05. Now, is it, or was it before this date? No, that's false. Let's go to the next. Well, is it, if it's before this? It is before this, so therefore that's true, then let's do that. So that's the logic you go through. Now, so to do this, we could end up doing this in multiple stages, but let's just try off the cuff here. So we're going to say equal to if. And you can see the if statement pops up here. And if you want, you could open up the box here. I'm going to try it without that for the time being. And then we'll go back and look at this again. So what we want to do is we want to write what they call a logical test. So what is the test? Well, the test is this greater than, or sorry, is this date less than this right here? So where they hired before. Before means less than, before this date. So a logical test has to have a logical comparison operator. Now, that might sound a little tricky, but what we want to do is say, is this less than this? Is that true? Okay, or that's either going to be true or false. Now, if I go a comma, that says, well, if the value of this was true and they were less than this, what do you want to do? Well, I want to take their salary and I want to multiply it by the 9%. And that would be perfectly fine if we only had one condition. But I have three conditions here, so I'm going to say, I'm going to put in another comma and go into, well, what if it was wrong? What if they didn't have this? Well, I got to put in another if. I'm going to put an if into the argument, and I'm going to say if what? If, I'm going to test again, if the same date is less than this date. If that's true, I'll put in a comma. If that's true, what do you want? Well, I want to take the salary and multiply it by 5%. That's the argument. Comma. If both of those are not true, that must mean they were hired after this. Therefore, I want to take the salary and multiply it by the 3%. And I'm done. So I can close the bracket once for the inner if. You can see here it's in red. I'm going to press the comma for the second if, which is in black. That's the major one, and push enter. And it comes up. Perfect. And that was what I wanted. I wanted the 9% would be there. But here's the problem. I wrote this without using any absolute referencing. You can see that right there. So if I was to copy this down, I'm going to get a mess. I'm going to get total inaccuracy because this formula here is shifted the whole table down. This one here shifted the table down again. This one here, you can see here, shifted the table down and so on. This one here's, oh, pick this one. There's. So what I want to do is I want all of those, all 5 of those to be set up as absolute references. All right, so let's go back and fix it. This one here, the red one, I can simply just select it and push F4, lock it in place. And again, I could just lock in the row because it could have a mixed reference, doesn't have to be an absolute. This one right here, this J9, that's absolute, good. The I3, that's this one right here, that's absolute. The J3, that's this one here, that's absolute. And finally, the J4 is absolute. So all 5 of those must be signed as absolutes. Doesn't change the results, but now when I copy down, it works as it's supposed to. So there are variations to this formula that you guys could do. It is one thing we could do, like I said, you don't need these dollar signs here because it would still work. Let's take those out. Let's just double check that I got that correct. So we could use a mixed reference. Now when you're doing this on the test, it would accept both. Now let's take that one, double click it, and there's no, it still works. Perfect. Another way we could have done this is by putting in named ranges in here, which is very interesting. we could have gone in and done name ranges. You guys might remember this trick. When you select a range, go into formulas, click on create from a selection, and say I want to create a range name of here based on those right here on the left hand column. Perfect. So when I click on this one now, it says I'm hired before. That's this one. This one here is hired on or before. This one has that, but we're not going to use it. So let me just say that we could have now replaced this with hired before. Does it still work? It does. All right, we could do the second one right here, and that would be this one here. And oh, it looks like I definitely did something wrong with that one. Hired on or before. That's definitely wrong. Let's just undo that. Undo, undo, and let's see what happened wrong. So that was, oh, I highlighted the wrong one. It was supposed to be this one right here. You can see how, and that's this one. So that's hired on or before. There we go. It works fine now. All right, so hopefully you guys get the idea. Now this will take practice. They will ask you questions in the simulation. They will ask you this on your assignment. They will ask it on the quiz, and I will definitely ask it on the final exam. Understanding how a multiple or nested if function works is one of the most powerful features that you can do in Microsoft Excel. As you can see here, we're verging from a formula into a program, because in fact that's what you've written here. This is no longer just an advanced formula, but it's actually a program, an algorithm, because you're asking it to follow a particular organized sequence. If the date is less than this, multiply the salary by 9%. Else, if the date is less than this, multiply the salary by 5%. And we don't have to write another if statement. If it's less than, if it's greater than this, do this, because there is only one more. We could have actually written this out a little further and had another if statement in here, and even had a third if statement in here. But we didn't. We don't require that. But we could have replaced this with another if, and said something like if bracket the date that they were hired is greater than, meaning after this date here, after date, what do we want to do? We want to take the salary and we want to multiply it by the 3%. Now remember that 3% has to be locked in and make it absolute, and push enter. And I forgot the extra bracket at the end, but Excel put it in for me. Thanks, Excel. I forgot to put in that. All right, so it still works. If I copy this down, all the numbers are still the same. Now look at the function now. If the first condition you hired before, multiply the salary by 9%. If that fails, let's write another condition. If the salary, if the hire date is before the second hire date, before or after that, let's calculate the salary at 5%. And then finally, we said if that failed, we could say if the hire date was after or greater than. You see, I changed the logical operator to greater than. Then let's calculate that at 3%. But this is kind of redundant because it's always going to be after that particular date. So we could have just put in the formula in here. This again is going to take a little bit of practice for you guys to do. So I highly encourage you to go in here and write this from scratch and work on that. All right, let's practice this again using another logical operator. We can make these questions more complicated. I'm sure you guys just want to love to hear that. Anyways, here's what we're going to do now. We want to ask the question, or we want to provide the employee with a raise. And what I'm going to do here is I want to write a conditional function that's going to put in here, you know, they get a raise. They're due for a raise. I want to know who gets a raise and who doesn't get a raise. Now, in the human resources department, the HR department, this is a very common question within companies, but it's based on a condition. The condition is whether they've been, you working for a certain amount of years, or whether they're a particular title, or maybe they're in a geographical location. Maybe they've worked for a certain amount of time. Maybe their salary threshold is too low. So there's different reasons on how to write this, and there's a lot of different conditions. So what I'm going to do here is I'm going to say if the salary is below the minimum threshold, and that they're a manager. All right, so what I'm going to do is I need to have some kind of these are my two criterias. So I'm going to have a criteria that if they're a manager and they're making less than this, they get a raise. I want my company and all my managers to make minimum of $70,000 regardless. So they should be due for a raise. But if they make over 70 and they're not a manager, well, of course they're not going to get anything. So they have to be a manager and they have to make less. So I'm looking at all my data here and I'm going to say, well, which one does it work? And I've got this already set up here. So let me just go back to yours. There we go. So I've already calculated this already, but I want to figure out who gets a raise and who doesn't get a raise. All these people here. So first of all, what I like to do is I like to understand what what the answer should be. So first of all, there's only one manager, two managers, three managers to begin with. Out of those three managers, this one here makes less than, okay, so this one right here is yes. I think we should give them a raise. This one right here is they're making 75,000 already, so no, they don't get a raise. And this manager here is making far less. So yes, this one gets a raise, and that's all there is. So only two get a raise. So just the first one here, Adams and Ling. Okay, get raises. But I don't want to have to manually go through and look at the data to put in this answer. I want the computer to do it. All right, so I've got a situation now where I want this and I want this to match. So the question is the salary less than this? And the other question is the title equal to manager? Those are the two tests. You could write the two tests out if you want to help you, logically organize. So is the test, is the salary less than 70,000? That's the first test. And the second one is the title, is their title equal to manager? All right, those are the two tests. And they both have to be true. It's not just one has to be true, they both have to be true. All right, so in that case, we're going to do something what they call a if statement with a logical operator. So we're going to use what they call an and. We want and, meaning that we want the first test to be true and we want the second if both are true. So if this is true and this is true, then we want to calculate or tell them yes, they should get a raise. All right, so we're going to say now that and is also function. So we're going to put in a bracket, and the first logical test is the salary less than 70,000? Well, we know their salary is here, and we know it's relative for that record. So I'm going to say that G7. Is it less than this threshold I have up here? Now that's definitely going to be compared against every single one in here. So I have to lock it in place. Again, I'm going to make it an absolute. I'm going to make it a fully absolute. It's fine. Comma. What's my second test? My second test is going to be, is the title right here? So I'm going to say, is the title D7, and it's relative to that record, so it's relative. Is it equal to, and I'm going to actually manually type in the comparison. So I'm going to say, is it equal to manager? And I'm going to put it in brackets because it has to be treated as a literal string of characters. It has to be literally capital M, just like it is there. If I use a smaller character, it won't work. All right, and then I close the bracket, and it returns me, look at the argument, it returns me back to my logical test. So now if I go comma, if both of those are true, what do I want to display? Well, I'm going to say something like, a raise or yes. Otherwise, I want to display maybe no. They don't get a raise. And close the bracket. All right, so what I've got now is I'm expecting it to come up with yes, which is great. Now I'm going to double click this just to double check that my 70,000 threshold is absolute. Everything seems to be working for the first one. Let's just copy it down all the way. We know there was one more, and it was this person here, and it looks like it worked. Perfect. All right, so there you go. So now, let me remove those. If I wanted to, I could even extend this to like, how much should I give them? So if they're a manager, should they be getting at least a top up? So they should be getting a raise, but how much should they be getting? So, you know, what is the amount maybe? Now I'm just going to make this up because this is not part of the book, but this is just, I want you guys to always be thinking about what other data should be entered into the system. If I'm running this, I would want to know how much more of a salary this person should be getting. Well, now, how many dollars maybe per year or as a raise should they get per year? Now, how do you calculate that? Now, you can pause the video right now and try to put your thinking caps on here and think about how much should they be getting extra? All right, now this is a pretty simple calculation. Okay, pause it. All right, now let's go over and I'll show you how to do this. I would do it like this, and there's different ways you could probably do this, but I would say, well, my threshold is 70,000. I want to lock that in, and I'm going to subtract it from how much they get. So the amount is they get $1,250 bonus or increase per year to bring them up to the threshold. Now, that's a simple formula. I should be able to calculate that down. Look at this. But if we're going to calculate this, it's going to also calculate everyone. So that's really going to mess it up. That's not really helping us out. So what we need to do is, first of all, say if this is a yes, then do the calculation. Aha. So we're going to go back down here and we're going to rewrite another logical test. We're going to say equal to if bracket, and the test is if this right here is exactly equal to, and I'm going to put this in quotes because it has to be exact. That's the test. If that's yes, if that passes the test, and that's correct, then I want to go in and say, let's take the threshold amount, lock it in, and subtract it from the relative salary. Perfect. Otherwise, I don't want to show anything. I want to just have it blank. So a blank would be just two quotations that put nothing in there. So let's check this out. Well, we know that one gets a bonus, but if I double click, aha, look at this. Now I only get to see, and I get to see exactly how much they get. So this person here, Adams, is going to get $1,250 increase because they haven't met the minimum threshold. So their salary the next year will probably go up. And what this does for me too is it allows me to go in here and say, well, I want to change this to $72,000, and it automatically updates. And we could say, well, what if we want to do something else? Let's say it's 80,000 and so on. You guys get the idea. It also now starts to merge into other records. You can see here that this person makes under 80,000 and they're a manager. So basically all three managers now have got a raise. All right, so I hope that makes sense. And again, practice this because, you know, I know when you guys go looking for jobs, and a lot of companies do test you guys, as I've mentioned before, with Excel. And one of the questions is they ask you to write a conditional if function. And this will definitely be on that test. So they do look for that. So make sure you do that. And it makes you just be able to write more robust spreadsheets, is incorporating conditional functions. If you can think of the questions and write the functions out, it just makes it so much better. All right, the third function we're going to look at in this worksheet is how to look stuff up. Now the lookup, so we did the logic, now the lookup. We've done a lookup before. We've done things like vertical lookup. And what we could do is like a quick lookup to find out what title is this particular person. Now up here I mentioned before that you could type in an employee number, and I would want to look up to see what title they are. So a quick search for their title, for example. All right. So what I want to do is I'm going to use what they call the index and the match functions. And to do this one, when what I'd like to do is be able to just simply type in an employee ID here. So let's say I type in Barnes's number here. Let's say I go 2521, push enter. And what I want is I want their title to pop up here. So I want to know what their title are. Are they a manager or are they an account rep? So I'm thinking, what's the best way of doing this? Now, we could possibly do this with a vertical lookup. And now there's a new X lookup function, which has now replaced this one, but it's very important to still understand how the index and the match function works. So what I'm going to do here is I want to be able to type in an ID here, look up this entire table, and be able to match the ID from here and follow across the table until it finds title and look up that data. So it's trying to find a very specific piece of data based on, in this case, an employee ID. All right, so to do it, I'm going to simply just type in the formula to start with here, and I'm going to have to modify it slightly here. So what it is, it's called the index. The index is actually indexing or looking something up, just like regular indexes look things up. And within the index, we're also going to look up or match together. And when you look at a formula like this, there's a formula, a function within a function. We have to follow the rules of math, the BEDMAS, brackets, exponents, decimals, add, subtract before you multiply, or multiply and divide before you add and subtract. BEDMAS. You guys can look it up. All right. And so what we're going to do first is we have to do what's between the brackets first. So we look at the first one here, and we have to go inside the brackets. So we have to actually look at the match function first. So what we're going to do here is look at match, and we're going to say, okay, well, if we're going to do match, we have to look up a value. And what are we looking up? So I want to look up the employee ID. And I'm going to look up the employee ID where? So my second argument right here is look up in a particular, what they refer to as an array. An array is simply a collection of like objects or elements. And in this case here, I'm looking up an array of all of the employee IDs. And then from there, that's all I'm going to do. I'm going to try to find a match. So what this does is it takes this number here and it looks up all in here and it tries to find it. Finds it right. It would find it right there. And it would return a number back. It would return a value back to here. All right. So if I go back into, I could do a formula to break this down. Let's see here if I can do this rather quickly. All right. Let's have a look again at this. All right. So again, what I'm trying to do is I'm trying to locate or look up a particular employee ID and match it up and display their title. Now, again, what we have to do is we have to locate within this data set what particular record I'm looking for. So you can see here it's the 1, 2, third record down, or the third index down. And then it goes over 1, 2, 3, 4 over here to pull out that particular account. So to do this, I've got to go into the match right here. And the match is trying to match up my employee number, okay, which is B1. And I'm going to match it up with the array of all the employees. So you can see here that 2521 is the third index down, 1, 2, 3 down. And also, I've got this optional one. And this optional one here is called match type. So match type, if I was to remove that, it says, do I want it less than this employee? Do I want the exact employee or greater than the employee? Well, I want the exact employee number. So I'm going to put in a 0 in here to make sure that even though it was optional argument, it needs to be in there for this example because it's these numbers that have to be entered. So what does this whole match do? It simply says take the 2521, look at the array here, match it up, and return an index value, 1, 2, 3. So all this does is returns an index value of 3. All right, once that's been done, then the computer goes back to the index and says, okay, let's look up in the entire table here, and let's find the index, the third one, the third record, which is Barnes here, and then let's display the fourth column, 1, 2, 3, 4, which is title. And what do we get for an answer? The account rep. Is 2521 an account rep? Yes, they are. What if we change it to 3824? Well, they're a manager. Perfect. So by typing in this right here, I can get their title displayed somewhere else. Now, I might use that for calculating bonuses and thresholds. I can expand this even further. One quick little feature here that you guys could do, instead of having to manually type in here, these are all unique records in here. So what I could do is I could actually insert a validation rule here. We'll look at validation a little later, but I wanted to introduce it to you. So a validation means that you want to put in data into a field that's only conformed to a certain value. I don't want to be able to type in like 9999 in here, because there is no record with that. So I only want all the records that are right here. So what I can do is under the data, because we're dealing with data, we want to go into the data tools, and this one right here, it's not very clear, but it's the data validation rule. We can make a data validation option in here to allow only a list of only this range right here. Now, what that does when I'm finished with this is it creates a dynamic control that only allows me to select those ranges. So what I've done here now is I've automated this. Now, if you take a look, I can go back to the first record and select it, and they are a manager. I could select the second record, and that is a count rep. So you can see how you could automate things if it's a matter of inputting. And we could input in this field as well. But for now, for this video, I don't want to get into too much of the data validation. But again, that was under the data tab, the data tools, the data validation, and it's buried under data validation here. It's allowing the criteria of a list and the range that I want to display. All right, so that pretty much wraps it up for the logical test right here. So I'm going to carry on to the database functions. All right, so the database tab down here, again, has a similar type of data structure that we've already seen. But what we're going to do now is we want to do some calculations and some statistics on summarizing some aggregate information from the data structure, meaning things like what is the average salary, what is the lowest salary, what's the highest salary, and what's the number of employees, that sort of thing. Now, but I want to do it for specific questions. So here's the data that I'll be looking at. This is referred to as the data table right here. And down here, this is what they call the criteria range. That's this range right here. And then we have the output range of what the results are. So for example, what I've got down here is I could put in like Boston, and you'll notice over here it changes to Boston and what the Boston manager makes on average, what's their lowest, their highest, and their number of employees. If I take out manager, I just want Boston, period. It tells me that there's 5 people that work at Boston, their average salary, their low, their high. If I change this to Chicago, you can see here, there's the average, high, low. And what that's doing is giving me a dynamic option here to create a very rapid way of creating asking questions of the table. Now this is a pretty small table, but it's good for this demonstration. So as you can see here, I could put in, if I put in just one employee here, like let's say I put in this employee here, they work in Chicago, I don't even need Chicago, but it just tells you what they are as well. I probably wouldn't ask that kind of question. But I could say, well, what about all the managers? How many managers do we have? We have 3 managers. The average salary is $70,000, which is good because our threshold is 70. The lowest is 65. The highest is 75, 800. We can ask questions of that. And then also, if we want to know who those records are from the table, we can output them in this area. Now, how do we do all this? All right, because you guys don't have access to all of this. So to get started, I'm going to first of all set up go under data, and we're going to go into advanced filter options. So when you go into data advanced filters, you get the advanced filter option questionnaire right here. And it comes up with 3 kind of criterias. Filter the list in place, copy to another location, that's what I want. I want to copy the data from my criteria from here, and I want to copy it down below. Now it says here, what is my list range? My list range is all of my data. It's basically my data table. So that's question number 1. It's my data table. except I just messed it up here because I copied it over top. So that's all good. Have to be redone. I'm going to go backwards here. I should do include, and by the way, also include the titles. All right, and then the second one right here is what's the criteria range. The criteria range is the titles and then what's going to be entered into this row right here. So actually I could almost color that because that's what needs to change. And then finally, where do I want to copy it to? I'm going to copy it to down here in this starting at this range and then flowing over, depends on how many records there was. Now, if there's a lot of repeat records, we could just pull out and say unique records only, but that's not the case. So now if I go OK, it's going to filter out everything because I had no criteria here. All right, so if I did have a criteria, let's say I typed in Boston right here. There's my criteria. In fact, let's just highlight this in maybe a nice yellow, knowing that that's my input range right here. And just put on a little box there. There we go. So I want to filter this out. I want to filter out all the Boston records from here, and I want to put them down there. Well, I do it by going into my data. Again, advanced filter. This time I've already got everything set up. I want to copy. Make sure you click on this copy to another location. Otherwise, it filters the top range out. And then from here, all my ranges are set. I click on OK, and it should pull out just Boston, and does it. And there's all my Boston records right there. If I want just Boston records with, or here's another one. Let's say I just want my account reps. All right. For the entire data system, I go back up into advanced, click on copy. Everything's in place. I click on OK, and there is a list of all my reps. And I can perform data calculation. I can say, well, you know, what's my average? How many people? What's my minimum? What's my maximum? What's the sum of all that? I can do all that aggregate calculations. So that's what they call an advanced filter in my data set. Now, we also want to calculate what are some of the data aggregate functions. So this one's called D average, and then we've got D minimum, D maximum, and the number. We could have D sum as well. There's a lot of them. So let's start off with how does this work? Well, the D average works by having an argument that says, well, let's look at the entire database. So all you have to do for D average is highlight the entire data set as the first argument. The second argument is, what field are you trying to average? Now you'll notice here that the field has to be put in quotations, and it also has to make sure that your data set has to include that. So I'm saying let's use the second criteria, which is called the field. Okay, let's try that again. And then the third one is what's the criteria? And you see the criteria has a name here. What's the criteria? And that's simply because we've selected this entire range here and we named it criteria. You remember that from an earlier video? We call that naming a named range. I could have just typed in A25 till F26, and that would work just fine. But whenever I have an option to use named ranges, that's how it works. All right, how does the low work? Well, the low works identical. You're taking the entire database, you're taking the name of the field. Now in this case, instead of typing in quote salary, what I've done is I've actually highlighted salary this time. So you could use a different approach here. You could either type in quote salary, or you could type in the actual field where salary resides. So just another subtle modification to that. The D maximum is basically identical, except they use the word D max instead of. Now, the number of employees, the function is count. One of these we could do is, what's the sum? Could we sum them up as well? Well, could we sum up how much the reps make? Okay, so let's do that. Equal to the D sum bracket. What's the database? Okay, well that would be all of the data, okay, including the titles. Perfect. The second argument is the field. Now I've got the choice of typing in salary, or I've got the choice of typing in the field reference of, I think it was F2. And then the criteria. The criteria is this range right here. And when I highlight it, it automatically knows that that's the range name. And I close the bracket, And sure enough, all of the reps' salaries equal $773,920. Now let's change that to manager. And now I've got the calculation for the total salary. There we go, total salary. So we've just added another aggregate calculation in our D sum function right there. All right, well, I hope that makes sense, showing you how that D function works. Let's move on to the financial functions. Now, the financial functions we've looked at before, but this is just using a, just carrying on with the financial functions. Now, under formulas, we've got financial, and you can see here there are lots of financial functions. I think we've only looked at a couple, and the one we spend a lot of time with on is this, the payment function, but you can see here there are lots of them in here. So really what's important for you guys to understand is how functions and arguments work, and then how to apply them, and then how to look up, you know, if you're trying to figure something out, what function name it is. A lot of these I have never used myself. They're just too specialized for my own personal use, but I could figure out any one of these once you understand how functions work. So to get started, we're trying to calculate cumulative interest and cumulative principal. There's a lot of different functions going on in here. So to start off with, we're looking at the payments. Now, I'm going to start off with $450 payment, and that is a input from you. So I'm going to color it yellow. This is the annual percentage rate. Again, that is how much you're getting as an annual percentage rate. 5.25 would be very nice to get today. A number of years. And then the payments per year, what is the frequency? So all of these are really inputs that you guys can change. So you can say, well, I want to, you know, pay, you know, just $300. I'm only going to get 2% interest for 5 years, and I'm paying every month. And it recalculates the entire table structure. All right. Now, we could take our information and we could calculate what is the present value today. So in today's dollars, what would I need to get the same result, which they call the present value. And the present value has arguments just like the payment does. It's just kind of figuring out what the present value is rather than if you know what your payment is. So in this case, I know what my payment is. It's 300 because I'm kind of working backwards here. And I want to go back and find my present value. Now, to get the present value, I need to know what rate of interest I'm getting, what's the number of payments, and what is my payment overall. I don't really need my future value or what types. Those are optional, so I don't need those two. So if you look at this, I'm going to type in my present value. I also have a negative sign here. Well, what's the negative? Well, in other videos, I think I've mentioned that if you don't have a negative, it shows it as a negative amount because this is what you need today. You don't have that, so it's showing it as a negative. So sometimes people don't like to look at those numbers in negatives, so they put it in a negative here, and it changes a negative into a positive. All right, so what is the present value today to get the end results in 5 years if you put in 300 payments at 2% interest every single month? You would need $17,115.71. All right, now to calculate that, we just simply use the PV formula. And because it's a one-time, we don't need any absolutes. I'm going to say I'm going to say here that E3, that's my periodic payment. Now I'm going to need a periodic payment, means what is my payment per interval? Well, I get 2% annual percentage rate, but I'm paying 12 times per year. So therefore my periodic rate has to be divided by 12. That's my interest rate of 12 divided by 12. Sorry, my APR is 2% divided by 12. So that gives me a fractional periodic rate of just 0.167. What is my number of payments? Well, the total number of payments is how many years I'm going to pay for and how many installments per year, and you simply multiply those two together. So my PV is calculated by taking the periodic rate. That's my rate right here. That's the fractional rate. My second argument is the number of payments, which would be 60, and my monthly payment, which would be 300. That comes up with my present value calculation. All right, I hope that makes sense. And I will be asking, a lot of these questions in the assignments again, and on the quiz and the final. So make sure you pick that one up. Now, in this last one below here, we're trying to calculate the what would be the interest on the payment for each payment of each month. That means how much is the interest that you're getting based on a monthly payment. So I wanted to know not my payment, but my interest on my payment. And again, because it's the interest, it's going to show up as a negative, so I'm going to show it as a negative here to calculate that. Now, this one here is going to be by taking the rate. Now that's the fractional rate, so that's this rate right here, and it's a mixed value because I'm going to pull down, so I'm going to lock in the row, not the column. And then the second argument here is the per, and the per is which unit are we talking about at this particular time? What's the period that we're talking about? Well, I'm just talking about the first payment period. So I'm going to go over here, and this is relative, so that's going to show up as A8. And then the number of periods, the total number of periods that I want would be up here. That's 60. That's fixed. So I'm going to lock in the row. It's a mixed reference. And then finally, I'm going to select what is my present value. And that is up here. And again, I'm going to lock in the row so that I'm always going to maintain that value as I pull down. So as I pull down and I drag that down, it's going to maintain those as locked. But this one over here, this is the per, will be relative. So that's kind of the tricky part to this one. And all we're doing is we're looking for what is the interest that month on that payment. So it's $28 of interest if you're getting charged 2%. Now remember, it was at 5.25 before, and you can see how much interest impacts your interest paid if you are paying a lot of money on your interest right here. All right, the principal repayment is very similar in concept, so I won't go through this in that much detail, but you get this sort of the same idea that the principal that you paid back. Now the principal is simply, you could probably calculate the principal by simply just taking equal to how much you paid minus the interest. That's the principal. So we could write this as a very complicated formula, or we could write a function, or we could write it as a very simplistic formula. Now, if you notice I copy that down, it's the exact same number. You see here how complicated this is and how simple this is? So you can do things easy or you can do them complicated. Now, unfortunately, you do need to know how the principal repayment function works, so I would encourage you to do that. Now, what is the end? Well, let's go back up here. What is the end ending balance? Well, the ending balance is simply taking how much money the loan is, or the present value of that loan, and subtracting what you paid down on it, and then that gives you the ending balance. And then the next one here is the same thing. How much do you have left over to how much did you repay? This one right here, though, is simply dragging this value and bringing it as the next month's. At the end of this month, you're bringing in as the beginning of this month and carrying it on. This will take a little bit of time. I definitely encourage you to go through the simulation. Explains it again as well during that. The last two here is the accumulative interest payment and the accumulative principal. These two also could be easily calculated. You can see here how complicated the formula is. The minus the cumulative interest payment has all these functions, right? But we could probably make that simpler by just saying equal to what was our first month interest. There we go. All right, what's the next month interest? Well, it's simply just plus the one above it plus the one that we paid for that month. And we could write this in a very, very simplistic way. Look at this. I could write this as this formula, as simple as that, or we could write it as complicated as this. Unfortunately, you guys have to learn how the accumulative interest payment works and the accumulative principal works, which is all relatively the same as the ones I just demonstrated over here. Anyways, I try to keep these videos down to an hour. I hope that this has been insightful. And this pretty much wraps up chapter number 7. So I hope to see you guys online, and I kept it under an hour. Okay, guys, see you later.